title's attracted you to seeing this video, you'll think, what has he got here? Well, I've never seen one before till I bought this off eBay about 4 or 5 years ago. And it's a PT40 masquerading as a Spectrum M8. Now, we don't have a lid for it, but I'm sure we could sacrifice an ordinary PT40 for if we ever got it to go. So, as ever, made by WorldSound Electronics in Taiwan. Our friend Mark G7NDJ, also known as ZX2, has already tested this and found it doesn't work at all, hence the red sticker with our stock number on it. So yes, it does need a different power lead, it does need a grommet, but we'll see whether it's at all repairable. So we don't have a lid. That doesn't matter because I think we've got quite a few PT40s and we could sacrifice one. It's got the wrong screws in it. Now, the Lowe TX40 is the posh version. And it has extra circuits that this doesn't have. So if you've had a standard PT40 and you think it's dire, and then you go on and buy or get put off buying a Lowe TX40, it is a different beast. The Grandstand Hawk is also better version. It's not as good as the Lowe TX40. So here you go. There is no PA facility on this version. So this is the cheap one. So if you see the version with the PA, that's the better version. So you've got the one with the PA, you've got the Grandstand Hawk, and then top of the shop you've got the Lowe TX40. So this is going to be right at the bottom, and these were an old-fashioned design when they were produced, and they're a swine to set up, and they've got a lot of circuits that you wouldn't normally have. So the information I have, we've got a circuit diagram, 2 versions of, for the Grandstand Hawk. So this is going to have the PA facility that this set doesn't have, but otherwise it should be the same. And then we've actually got the service sheet, which was one of the trader service sheets, for the Lowe TX40. So this goes into jolly good detail with the controls. We can use this to help set this up because some of the things are the same. For example, you have to set the, I seem to recall you have to set the 10.24 reference oscillator for the phase lock loop chip at 10.24, and then you have to fiddle with the transmit because it has a delta tune that actually works very well, and it doesn't allow you to set the reference oscillator in the usual way, which would be normally putting it into transmit on channel 20, which is 27.79125, and trimming it for 27.79125, because you end up with the receiver being out. So it is a bit of a thing, and we'll be reading the service sheet there and reading between the lines because it is a slightly different beast. So without further ado, we'll try and find a plain screwdriver. They're probably all in the organ workshop because we don't often have plain screws in the electronics department. Oh, we have got a screwdriver. One I use for chop blocks, one of those made in Sheffield Steadfast ones. So those screws aren't really much use to us. PT40s are one of those sets that if you buy a box of radios, you always end up with one of those really swish looking realistic 2015s, the 80 channel ones, also known as, oh come on, oh good grief, it'll come to me, you'll all know the one I mean, which never work. And they always come with a PT40, and they always come with some type of communicator, and that's every box of sets has got those 3 in, and somebody who's unknowing will think, wow, that's a swish looking set, as they see the one I can't remember. So we've got a speaker, and it's not the right speaker. That is actually for something like the Binatone 5-star. It's a bigger speaker than normal. So we'll put the soldering iron on and be ready to unsolder that. We've got a wire that's dangling. There's nothing to beat that. We've got a resistor. Was it too loud with that? Yeah. You know what? These are reliable. Well, they are in my experience. So I'm best off putting that somewhere safe and putting it in a radio that needs that speaker. So we'll connect it up to our inevitable crocodile clips. Well, I can't smell any smoke. Connect it up to the test instruments. So as I say, these are old-fashioned design when they actually came out. That volume control feels loose. I think we'll have to have the front off and just check that the controls are tight on the spindles, but again we'll get the thing to work first. So I don't know if I showed you the front. So there's this Spectrum M8, and that's clearly not the right knob. Select channel 12. Oh, we've got a bar out. I can't say we're bothered about that, but may even be a wire off. Anyway, we'll worry about that later. One of the things about the Lowe TX40, I was distributor for those when they were out, and we had to turn a lot of them down because a lot of them came out of the box doing 5 watts. So that, you think, is a problem these days with them all doing 2.7 watts out of the box. But you know, some people do like them to be spot on, and we got 1 or 2 moans. So microphone, let's look at what it is on our list. Is it the standard, shall we say, Cybernet type of pinout? So what is it under? WorldSound? Is it under? I'll tell you what, let's look at it as a grandstand. A grandstand Hawk. It's pinout number 1, so it's the Cybernet mic. I don't think it needs an earth for the audio. There we go. Oh, it does. It does. It definitely got louder. So it's certainly doing its FM hiss. So switch off that. RF gain to full. Power to high power, which is in the attenuator off position. And I'll put picture in picture on. And hopefully, oh, we're not on the right, the camera's not on the right one. That's better. We'll switch the test instrument to the 3 watt scale. So full scale deflection is 3 watts. And it's doing 1. and on low power it's doing 300 milliwatts. And it's not, what's it supposed to be? It's on channel 20 and it's 10 channels wrong. Or am I not right on here? I'm not right, because it's on, it was channel 30 I'd got it on. That's better. 79299. So that is miles out. And as I say, it isn't straightforward on these sets. So let's see if we've got any receive at all. So as far as receive goes, we'll just go up to the synod meter, then we can see how it's performing at the moment. So for 12 dB it is doing 2 microvolts. Well, of course it should do much better than that. So I think we've got a played with set that's tired in the first place and obscure anyway. Would we advertise this on eBay as mega rare? As if that conjures up more money. Have you noticed these adverts? Mega rare HMV radiogram, and I've got 28 of them exactly the same in my storage department, you know. Mega rare, £2,500. Yes, I do. It does amuse me. I've paid like 10 for mine. Yeah. Right. So we start with transmit, but we've got to do this frequency thing exactly as it says here. So there's a layout. There's going to be a layout difference. And I think, if I remember, it affects the receive more than it does on the transmit. I'm not even sure that the controls have got the same. No, they haven't. No, everything's labelled differently as well, just to make things more awkward. So the trimmer capacitor for the frequency reference on the low is CT2. Can't even seeing anything on the board. So we've got to find a test point, and that test point is test point 1, and we need to adjust locate test point 1. This is going to be about 2 hours, this video. Jumper 1. So do we have to look at the circuit diagram to work out where test point 1 is? test point 4, test point 2. Test point 1 is in effect the output of L4. So L4 on the low is that one. So I wonder if L4 is T1 on this one. Well, it looks in the right kind of area. The other way to look at this is see if the parts for the grandstand hawk make it easier to. So L4 is still called L4 on that version. You know what? I've got a sneaking suspicion that all these three circuit diagrams are the Lowe TX40. I don't think any of these are the ordinary PT40 at all. They're all T something on this, they're not L something at all. So basically the third transistor in the receiver is where we're supposed to be doing this test point. Okay, so I think we're going to have to do some of this my way. And then if we make any errors, simply go back on it. But this setting the frequency thing is important on these sets. So what we'll do, we'll get a frequency probe onto the, especially if I can undo it. There we go. So put that into our frequency counter. We'll select the frequency counter. Put that to earth. We'll monitor. Oh, this is a giant plug. I'll not get this in the space, I'm sure. We'll monitor the phase lock loop chip. Crystal oscillator input, which is going to be pin 11 and 12. So let's put that to external. Have we got anything on pin 11? Not that we can read. And pin 12. There we go, 10 point, not quite 24. So we'll set that to 10.24046 as it says in the Lowe manual. If it'll go. No, it's not going to go. That's the highest it'll go. So out of interest, I'll just see what that now gives us on transmit. Actually, in fact, that's high, so that's all right. I'll tell you what, we'll do it the wrong way. We'll set it this way, like you would conventionally. We'll probably end up using the marker oscillator. And I can't bring that down. I think it's variable resistor 4 affects the delta tune. Yeah. That's the lowest I can get it on there. So 79138 appears to be the lowest I can get it. Just prove myself. Seven 79133 is absolutely fine. I mean, just 8 above, that's fine. But I might have to jiggle with that with the marker oscillator. So that was the first thing that didn't go right. I think we're going to have to do a lot of guesswork on this. Let's go back to the transmit. Now it's drawing quite a lot of power, this. It's 800 milliamps, yet it's only producing 2 watts. So I would expect it to be doing more power than that for that input. So we're going to guess, because that's what it is, we're going to guess that, I'm just thinking, are we here for the transmitter, or is this going to be received? That doesn't affect it. that does affect it, so we're spot on there. Does this affect it? Yes, it does. Wow, that's brought it up. Does this affect it? Yes, it does. So does that affect it? It's broken. We're now on 3.2 watts. Don't think that one does. Let's just check that one. That doesn't appear to. Just check that one. That also doesn't appear to. So it looks like these three transmit, 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 and obviously those. So we'll just peak these. So 3.2 watts. 3.2 watts. 3.2 watts. We've now dropped off frequency as we've warmed up. 27790. So we'll just trim that in. There we go. Just check that one. 3.2. Let's see whether we can get anything out of it. That one. This is a broken coil. I think this had Mr. Twiddle in this one. Yeah, I've tweaked it down to 1.5 watts. So that one is broken. Let's see whether we can get anything out of the final one. And that one's broken as well. I can see that it's in the optimum position. Now we've got another one there which I think is done with the spectrum analyzer. So we'll just put the spectrum analyzer on and just check that that's the case. I'm going to have to unsolder that and get out the debris and see if we can find a replacement core out of a scrap worthless, useless set. What I think I need to do is to take a photograph of this and print it out in black and white and then colour all the adjustments for future reference, because we've got another 2 or 3 PT40s on the shelf in one way or another. So we'll just put this into auto find, just put the spectrum analyzer on the screen and auto. Wow, that's alright. So we'll just find a second harmonic. So I'll put in frequency 55 megs. Especially if I press the right button. Frequency 55 megs. I put in 55 kilohertz, didn't I? Tune around. Why, I'm surprised. It's clean as a whistle. So we'll just go back to, we'll tune that one to maximum. Not that's gone up to 3.5 watts, and we'll just see how clean it is now. So we've got nothing on the harmonics. Let's go down to 27. Put that in. Frequency 27 megs. Excellent. So I think if we get that out, I think we're going to be okay there. Right, I'll pause the video while I get the soldering iron on. Okay, so there's my black and white photo, and I've put the red pen on the TX ones, noting that's done with the spectrum analyzer. So I took that out, and it isn't a open coil, it doesn't go all the way through, so I can't get out the core. The only way to get the core out is drill it out, and the core former, coil former started to break away. So we're going to leave that, and the radio does 3.5 watts when warm. What's it doing when cold? Yeah, 3.5 watts. So that's how it is. I'd rather have it doing 3.5 watts and not working at all. So one day we'll pick up a scrap chassis from somewhere, but PT40 is something we haven't got as a scrap chassis. So let's look if we can find where deviation is. We've got lots of presets, and we know that is to do with the frequency adjust, and it's to do with the delta tune. So we've got to find RF meter, and we've got to find, don't know whether it's got low power, so let's see what presets we've actually got. Well, I'll tell you what, let's see, because that's in the transmitter, we'd expect that to be RF meter. And it is. So what they're going to want you to do is to have it in the centre of the red zone. So that's transmit. TX meter. Second harmonic trap. We know that is delta tune. So we've got preset there. Could easily be the squelch. We've got one there. Could easily be the squelch. One's going to be the meter. Have we got one lurking down there? No. We've got one there, and there, and there. So chances are, I wonder if this, which is near the audio IC, I wonder if the preamp in that chip's used as part of the speech processing for the transmitted audio. So in which case that would be deviation. So let's see if I'm right. One, two, 1, 2. I can't see any deviation. Oh, we're still in AM from yesterday. Wallow. Let's see whether that affects it. No. We'll see whether that affects it. No. We'll see whether that affects it. Yes. Testing 1, 2, 1, 1, 2. That's spot on. I just wouldn't expect that to be deviation, but it is. Wonder where the marker pens are. Only found the red one. So I assume we've got RF meter, sorry, S meter and squelch will be what's left there. Right, so we'll move over to the receiver. Let's just listen to what it sounds like. Testing 1, 2, testing 1. Lovely. Okay, receive. So the first thing we're going to have to do is to get this on frequency. So with the delta tune in the off position, we'll get our cheap Chinese signal generator set up as a marker oscillator. It's on 10.695. And in fact, without anything plugged into it, there's a bit of wire. I think we adjust that and then readjust the transmit. No, we don't. Go back on transmit. So we're happy that's about where it should be. Going up, not down. And then, tell you what, we'll put a proper probe into this. It's the little bit of wire wasn't clever enough. Hang on a minute, where's my... I'm supposed to be on this channel, not that channel. There we go. Well, that sounds to me on. So we'll just recheck transmit. Wow, miles out. Does this affect transmit then? Yes, it does. Aha, that's where we're running into trouble then. Right, we'll switch that off. We'll put the frequency counter back onto the crystal. We'll get that as near to 10.24 as we can. That's it. 10.2399. Then we're going to transmit. And it looks like we're altering it with this. Or are we altering it with that? Well, the Delta tune's now working as it should do. Let's see if we're still on frequency on transmit. Not quite. I'm going to leave it at that for now. Not quite on receive. Let's see if we can just get the detector better. So I'm assuming that this coil here in the corner's detector. It just sounds like it's miles out or it's miles off frequency, one or the other. Yep, miles off. That's it, it's miles out. This is the false lock point. There we go. Now we'll see what it sounds like with the marker oscillator. Spot on. Spot on. Good. Now we'll check it's still on frequency on transmit. Yeah. Right, let's see if we can work out what the receiver's doing. So as ever, we want 4 dB on the synod meter. Try and keep it attenuated. So I would assume that's the front end. I'd be right to as well. Drop it down. Drop it down. That one's matched up. Can't tell whether that's transmit or receive. Then the IF ones look to be, I'll just move the signal up a bit for these. It looks to be these. Wow. Whoops. Seems to be making much effect on that one. Let's put it at the sensitive end. No. Let's go back to these. And that one we're not sure about. It's probably transmit. We'll just go back to transmit. I think that is transmit. Did we ever find out what that one did? No, we didn't. Let's just check. So that must be transmit. So we'll go back to transmit. It is. While I wasn't looking, that's going to be VCO. So let's see what sensitivity we can read off now. It's 0.95 microvolts, so that's usable. Now we've also see if we can do the signal meter. So put an S9 signal on of 100 microvolts. So meter's there at the moment, and remember I fiddled with all these. It's not that one. It's that one. So one would expect that to be squelch, which we'll find out right now. So turn the squelch to full. We've still got 100 microvolts on the thing. Let's see whether it opens the squelch. No. Let's put a stronger signal on. Yep, that's the squelch. And that's its most sensitive position. It's about 300 microvolts, so but at least it does open. So now we'll go to the sensitive end. We'll set this now for threshold. Turn the signal generator to standby. Wrong button. And we'll set the threshold. Okay, switch the signal generator back on and see when it comes in. Oh dear, that's pretty lousy. 30 microvolts. Let's try again. Actually, I don't think we'll help because we've got dirt on the preset, so on the squelch control, so we can just clean that. Right, we'll try again. Right, switch the signal generator back on. Not very sensitive, 0.25. Sorry, I'm lying to you. It's 2.5 microvolts to come in. That's not going to be easy round scratchy corner. Anyway, that's how it is. So theoretically we are done. So I'll just make a note that that was squelch. So we've got some to do in yellow for the delta tune and frequency adjust and all that kind of stuff. I've got, as I say, I've got quite a few PT40s to do, so I may as well get myself into the swing of them. So I'm going to plug it into the roof aerial and see whether people sound right. It's all right using the instruments, but sometimes you can adjust things the wrong way and still get the right results on the instruments. "19, Roger." Just see what it sounds like if I talk on it from my walkie-talkie. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. Well, that sounds right. Roger. Okay. Well, I'll go and have a cup of tea. And I don't know whether we've finished, so I'll pause the video. Right, so that speaker's going to fit, so we'll put the smouldering iron back on. A Monocore SP3. I don't think these are much power handling, or it's probably BS if it is, but I'm sure it's adequate. Half a watt. So it looks like it's just a matter of bending these tabs. Not all of these have been bent back, so we'll slot that hopefully in. He says hopefully. Where's my best rusty screwdriver? I think this is a rubbish way of mounting speakers. Luckily I've got exceptionally strong fingers. There we go. Now I'm not sure why we've got this wire here. This is the trouble when the sets you don't see very often. One of the things we'd better do is to look at where that goes in another set. That doesn't mean on this video, but something I might need to do behind the scenes. But for now, we will assume that where they've got this wire to is more or less where it should be. Well, I reckon that speaker I took out is virtually irreplaceable, so it's probably worth as much as the set. I can't imagine that the reason that the display's got a bar out, I can't imagine it being a faulty display, because surely this kind of set can't possibly have got the kind of hours that would have caused the display to fail. That's not normal. Oh, I've still got the extension speaker plugged in. So what they've got as red is negative. Now remember, this isn't the original wire, so it doesn't matter anyway. We'll get it right while we can. I think Mr. Chip is wanting to do a test on this, so I'd rather look at other things behind the scenes so we can actually get this tested. I'll leave that out. At least it's on its own speaker now. One on a Roger. Right, I think that covers it. We'll do some more PT40s and we'll probably get to grips with them, this version a bit better. So I'm fine with the Lowe TX40, we've got the manual, but it's these cheaper versions, which I haven't done much with. And I know there's another two on the shelf in various names. So thanks for watching the Spectrum M8, which is a WorldSound PT40 cheap version without the PA, and we don't have a lid for it, but who cares? Thanks for watching.